there are the two balls A and ball B. Both have the same masses and both are moving with the same speed of 5 meter per second in the opposite directions. Okay, so at one instant they collide. So the collision lasts for 10 per minus 3 seconds. Means the two balls will be in contact for the time 10 per minus 3 seconds. Okay, after that, they rebound with the same speed in the opposite direction. Our ball A will be moving in this direction and the ball B will be in this direction. So, they are asking us to identify which of the following statements are true. So, when you observe the options, you can see that they are asking about the impulse imparted on the each ball. Means we need to find the impulse of the each ball imparted on the each ball and the force exerted on the each ball. And you can observe that the impulse and force which are given in the options are in the SI units. So first, let us convert the masses of both the masses in the SI unit, that is in kg. So they have given that it is 50 grams. So when I convert it into the SI unit, I get 50 into 10 power minus 3 kg. Now they are asking us to find the impulse imparted on the each ball. So for your kind information, whatever the impulse imparted on the each ball, it is actually the change in momentum of that ball. So impulse, which is denoted by J bar, it is actually the change in momentum. So now we want to find the impulse of the ball A imparted on the ball A. Then we need to find the impulse change in momentum of the ball A. Okay, in order to find the change in momentum of ball A, let the quantities in the rightward direction, that is towards the positive x-axis, let be considered them as positive, and the quantity velocity or the quantities which are in the negative direction, that is in the left direction, let them considered as negative. So velocity which is directed in the rightward direction, let it be considered as positive. The velocity which is directed in the left direction, let us take it as negative. Okay, now we need to find the change in momentum of the ball A, that is P final minus P initial bar. So here P final is, in the final you can see that the velocity is directed towards left. Let us take the velocity as negative. So I can get that MA into minus VA. Okay, minus P initial momentum here. In order to find the initial momentum, MA into VA, here the velocity of the ball A is directed towards right. So let us take the VA as a positive. So MA VA I can get here. Here I have taken positive. So when I simplify this, I get that minus 2 MA VA. So when I substitute the values, I get the initial momentum, the change in momentum of the ball A will be minus 2 into, okay, my change in momentum of the ball A will be minus 2 into 50 into 10 power minus 3 into 5, that is kg meter per second. So when I solve this further, I obtain that 0.5 Newton seconds, that is kg meter per second can be written as Newton seconds. So this is the vector form, that is this is the about change in momentum of the ball A, that is nothing but impulse. They are asking about to find the magnitude. Okay, here the magnitude, when I find the magnitude of the impulse imparted on the ball A, it will be 0.5. Here it is minus 0.5. Okay, so we got the impulse of the ball A. Now we need to find the impulse of ball B. So in order to find the impulse of ball B, we need to find the change in momentum of the ball B, that is P final minus P initial bar. Okay, so when I get the P final, here in the final position, you can see that the velocity is directed towards right direction. Let us take it as positive. So MB into VB, it will be positive. Next minus, here initially the ball was moving in the left direction. Let us take it as, consider it as negative. So here the velocity of the ball V will be negative minus VB, because both are in the opposite direction. Both velocities of the ball be before collision and after collision are in opposite direction. So in the before collision it was taken, one time it was taken as positive and other it was taken as negative. So when I continue to solve, I get that 2 MB is our change in momentum of the ball. When I substitute the values, I get that, okay, 2 into 50 into 10 power minus 3 kg, here 5 meter per second. So I get that kg meter per second. So when I solve this, I get the change in momentum of the ball B, that is impulse of the ball imparted on the ball B, is equals to 0.5 Newton seconds. Okay, Newton seconds. So here you can observe that from both the you can observe that the impulse of the ball A and ball B have the same magnitude. Okay, but their signs are different. Here it is negative, here it is positive. That implies that the impulse on imparted on the each ball have the same magnitude, but the impulse imparted are in opposite direction. This is our first conclusion. So here, from here, we can say that the impulse imparted on the each ball is 0.5 Newton seconds. It is, they have given magnitude. It is true. So coming to option D, the impulse and the force on the each ball are equal in magnitude. We have seen that the impulse on the each ball was equal in magnitude but opposite in direction. We have seen already. Now we need to see whether the force exerted on the each ball is having the same magnitude or not. So let us find the force imparted on the ball A. Okay, force imparted on the ball A can be found by the impulse of the ball A impulse imparted on the ball A by delta T. Delta T is a collision it is a time for which the two bodies were in contact. That is, for what time the force exerted ball B exerted force on the ball A. So for what time it was exerted? It was for the 10 power minus 3 seconds. So impulse of the ball A was 0.5 Newton seconds. By our time is 10 power minus 3 seconds. So when I solve this, I get 500 newtons. That is, our force is minus 500 Newton seconds. This force, minus 500 Newton seconds force was exerted on the ball A. Coming to force exerted on the ball B by the ball A was impulse of the ball B, impulse imparted on the ball B by delta T, that is nothing but the same 0.5 Newton seconds by 10 power minus 3 seconds. So when we solve, we get 500 newtons. Here we can see that the force exerted on the ball A and ball B both are having the same magnitude, but their signs are opposite. That is, their directions are opposite. So from we can conclude that the impulse and the force exerted on the each ball are equal in magnitude and opposite in direction. It is true. Remaining options are wrong. So option C and D are true.